expression, all of that in a few. Y is equal to x cubed minus x squared minus x plus 7. Great. So you have this equation here, and your task is to find the coordinates of any stationary points on the given curve. Right? So you can just make a note of it. The instruction is find the coordinates of any stationary points on the curve. Any stationary points on the curve. That's the first part, and the second part is distinguish between them. Distinguish between them. Now, this curve may have more than one stationary point, and you will have to distinguish between the stationary points. Now, to do that, you basically have to say if it's a maximum, if it's a minimum, or if it's a point of inflection. Right? There are three things, or three ways we can describe a stationary point. It can be a maximum, a minimum, or a point of inflection. So we're going to do this one as an example, and then I'm going to give you another one. Can someone tell me what is the algorithm, or what are the steps that we use to determine stationary points of a curve? So we're talking. I'm going to give you 5 minutes. So differentiating minus x, what will be your answer? Come on, man. Thank you very much. -1. And when we differentiate the constant 7, what will we get?
0. Nothing.
0. Great. All right. So we have step 1, differentiate. Next, someone else. Not the person that told me step 1. Someone else. What's the next thing we have to do?
So for dy dx, we can put 0.
Great. Now, let me explain the reason for this, right? A stationary point is as I said, a maximum or minimum. Now, if you can remember, dy dx is actually the gradient function, right? And I want to show you something about the gradient at let's take this maximum point here. If you observe carefully, the gradient at a maximum point will be a horizontal line. Is that clear to everyone? The tangent will be a horizontal line. Here again, at this minimum point here, the tangent will be a horizontal line. Is that good with everyone? Can you see that?
Yes, sir.
So at any turning point or maximum minimum point, you'll have a gradient that, or a tangent that is horizontal. And if it is empty, remember, when the tangent is horizontal, or any horizontal line has a gradient that is equal to 0. That is why we can let dy dx equal 0. Because basically what we are saying, at the turning points, the gradient dy dx is 0. Right, so that is why when we are finding the turning points, we have to let dy dx be 0. We're simply saying at the turning point, the gradient of the tangent is 0. And as I demonstrated here, that is true. Look at this point here. I'm just taking a point random. You can clearly see that the tangent will not be a horizontal line. So at this point here, the gradient of the tangent will not be 0. Only at the turning points, you will have a horizontal tangent which will give you a gradient that is 0, right? So whenever you're finding the turning point, you need to ensure that you equate the first derivative to 0. Good. So who can tell us our third step? What can we do next? Come on, let's talk. Looking at this, there's only one thing we can do with this.
Solve.
Excellent, excellent. So the next step would be to solve, right? We are solving for x. Good. So this here is a quadratic expression. I'll give you 2 minutes to just, that 2 minutes is a lot, right? To factorize if you want to use the quadratic formula, whatever method, and let's get the values for x here. Please solve that equation.